In our last video, we talked about how to find standard deviations for portfolios, and to be able to plot in mean variance space. And we said that in order to find the standard deviation of a portfolio, you needed to know the standard deviations of the assets that comprise the portfolio and the correlations between those assets as well. And we said that we don't know what the standard deviation is going to be in the future, which is really what we want. And we don't know what the correlations are going to be in the future. So we have to make estimates, and we have to recognize that these are guesses. So we want to go back and use past data, but not saying that these past data tell us definitively what is the standard deviation and the correlations. It tells us what they were in the past, but it doesn't tell us what they're going to be in the future. So we're going to typically go back and use 5 years worth of monthly data, as we talked about in the video. And we're going to recognize that these are estimates of what we expect the standard deviations and the correlations to be in the future. And we may just say, for simplicity, the standard deviation, the correlation, but we know that it's an estimate of what we're expecting it to be in the future. Okay, so there's nothing wrong with using past data, okay, to make our forecast when we talk about standard deviations and correlations. In fact, that's pretty typical to do that. However, okay, for the other axis, for the y-axis in mean variance space, where we have expected returns, we never, ever want to go back and use past data and use that as our forecast for the future. For example, I could go back and say, well, gee whiz, let's take a look at what Apple has done over the last 5 years. And as I'm sitting here recording this today, Apple has gone up by an average of, I don't know what it was been, but let's just say it's gone up by an average of 25% per year for the last 5 or 6 years. Do I therefore say that investors expect it to go up by 25% per year? Well, if so, then everybody ought to go and max out your credit cards, okay, and borrow every cent you can and invest it into Apple if it's going to go up by 25%, if that's what you expect. Okay, but we cannot say that what something has done in the past is what is expected to happen. I'll give you a more extreme example. Okay, let's take a company, let's say like General Electric, as I speak this, that has gone down in the past, or any one of another companies before they went under. I don't even know if they're being traded anymore. But Sears Holding, which was Sears and Kmart, went way down. I remember not too long ago, a few years ago, when BlackBerry went way down over the years. I mean, I'm sure you can always think of some companies that have gone down, that have lost more than 50% of their value in the last 5 years. Well, if over the last 5 years, the stock has gone down by 50%, that's an average of 10% per year going down. Do we therefore say that the expected return is negative 10%? Of course, you can't do that. Nobody would ever buy a stock if we expect it to go down in the future. You would rather put your money under your mattress, okay? At least if it's under your mattress, it's going to stay the same value, and it's going to have a standard deviation of 0. If you put your money in a stock that you say is expected to go down, then it's going to have some standard deviation, and you're expecting to lose some money. That's going to be dominated by putting your money under your mattress, and that doesn't make sense. So we do not use past data, okay, when we come up with expected returns. What do we use then? How do we come up with expected returns? Well, the way we come up with expected returns is through a pricing model. And we're going to talk about 2 categories of pricing models. We're going to talk about theoretical asset pricing models and empirical asset pricing models. And we're going to learn pretty extensively about one example of each. With a theoretical asset pricing model, we're going to learn about the capital asset pricing model, oftentimes called the CAPM, which I suspect you had some exposure to in your first finance class. And as far as an empirical asset pricing model, we're going to learn about the Fama-French 3-factor model. Now, Fama and French have since extended it to 5, and I think even very recently to 6 factors, but we're just going to take their first model, which was a 3-factor pricing model, which a lot of people use. So let's talk here about what is a pricing model and what is the difference between a theoretical asset pricing model and an empirical asset pricing model? Well, a theoretical asset pricing model starts out with a set of assumptions. And it says, if we assume these things, then naturally what comes next is this, and then this, and then this, and then this, and then this is how the assets should be priced. So it starts with a set of assumptions and says that theoretically, therefore, this is the conclusion of how assets should be priced. Now, when we start out with a set of assumptions, if these assumptions were true, we wouldn't need to make them assumptions, okay? So in other words, for example, if I say, let me assume that the University of Oklahoma's football team is the Sooners, okay? Well, that's crazy. I don't need to assume it. It is, okay? It's the Oklahoma Sooners, okay? And Oklahoma State is the Cowboys, okay? And I think everybody knows that. So you don't need to make an assumption when something is true. You make an assumption when something is false, okay? Or sometimes true and sometimes false, and you need to make things simplified that way. So here's an old model that was told to me, more than 20 years ago, when I guess about 25 years ago, when I took a finance class. And as an illustration, so I didn't come up with this on my own, as an illustration of a theoretical asset pricing model, or a theoretical model where the assumptions are not correct, but it leads you to the correct conclusion. So let's suppose I go walking into a house in the middle of the summertime, and I open up the door, and I don't know where anything is in the house. And I say, man, I could really use some ice water. I need to find some ice. Where is there some ice in this house? And I think to myself, well, let's assume that I am a piece of ice. If I were, which of course is not a true assumption, but if I were a piece of ice, where would I go? What's the answer? The answer is to the freezer. So what do? We go and we look in the freezer. And what do we find? Lo and behold, we find ice. Now, here is a model that had incorrect assumptions, but it led us to a correct conclusion. So just because we're using assumptions that are not valid does not invalidate the model. Okay, now it might, okay, but it does not necessarily invalidate the model. So what we're going to be doing with the capital asset pricing model, and we're going to do this probably in the next video, we'll be setting up 7 different assumptions for the CAPM. And these assumptions are not true, but if these assumptions, if they were true, then it leads us to the conclusion of assets should be priced according to the capital asset pricing model. Now, the question is, just if we relax those assumptions, do we still get a valid conclusion? Well, it's already been proven that we can relax some of those assumptions and come up with a valid conclusion. It just makes the math a little bit more complex to do it. But some of those assumptions are untestable. We can't test if the model will still hold. So there's still a lot of disagreement as to whether the capital asset pricing model is a good and valid pricing model or not. But we're going to learn it. And the reason why we're going to learn it is because it's by far the most widely used pricing model, and it's the simplest, and also because there's a lot of other pricing models that are based upon the capital asset pricing model. If you understand the CAPM, you'll understand some of the more complex pricing models a lot better. So we're not going to be here and say that it is the pricing model and you have to believe in the CAPM. No, but you have to understand it. You can't criticize anything unless you fully understand it. So anyway, the theoretical asset pricing model starts with a set of assumptions and says that we're going to naturally progress, okay, and come to a conclusion about how something should be priced. And so it's kind of telling you the way the world should be. The empirical asset pricing model is taking a look not at the way the world should be, but the way the world is. And it does not start with any assumptions. It says we see some relationships that have held between stocks or indexes or something in the past, and we believe those indexes are going to hold in the future. In other words, we believe that X causes Y. Not just that X and Y are correlated, but that X has been causing Y, and X will continue to cause Y. And if that happens, then when we see X, this is what we should expect to see for Y in the future. That's an empirical asset pricing model. It's saying, based upon what I've observed in the past, here's the way I think things will be priced in the future. Now, the problem with that is what you have observed in the past may, in fact, just be a coincidence, may have just been a coincidence. It may not be that X is causing Y. For example, there was a 20-year period of time back in the I believe 1970s and the 1980s, when every year the team that won the Super Bowl, if they were in the National Football Conference, okay, or if they were originally in National Football Conference, the stock market went up that year. And if they came from the original American Football Conference, then the stock market went down that year, and that held for like 20 years. Well, it was just a coincidence, okay? But there was a big joke about that the Super Bowl indicator told us whether the stock market was going to go up, okay? When the Super Bowl was played in January, as it typically was back then, we knew by the end of January whether the market was going to go up based upon who won the Super Bowl. Well, just because something has happened in the past, okay, does not mean it's going to continue to happen in the future. First of all, as I said, it could be a coincidence. And even if it was causal, if X caused Y in the past, we have to ask ourselves, is X going to cause Y in the future? But if you say that, yes, it is causal or was causal in the past and you expect it to be causal in the future, that's what an empirical asset pricing model does. And the Fama-French three-factor model works that way. They say, here are some characteristics of stocks that are going to have risk premiums, and we'll be going through that. So what we do not do with calculate expected returns is look at past returns and say that stocks that have gone up in the past, well, they're going to just continue that same trajectory, and stocks that have gone down in the past, we expect them to continue that same trajectory. We do not do that. We either come up with a theoretical asset pricing model, like the capital asset pricing model, or we come up with an empirical asset pricing model, like the Fama-French three-factor model. And when we cut together with our next video, we will start to delve into the capital asset pricing model, starting with what are the 7 assumptions of it.